so this is the screencast for Honors Chem Unit 1 for objectives number 4 and number 5. So objective number 4 is identify properties of various types of matter. So we're going to talk about classifying matter as a pure substance or as a mixture. So some of the basic properties. This chart or table will be an excellent resource for you. I would jot this down in your notes. You don't have to write down all of this material like the examples that they put down underneath it, but just know that matter is separated into two things, either pure substances or mixtures. Pure substances are the elements and the compounds, and the mixtures can either be homogeneous mixtures, which we call solutions, or heterogeneous mixtures. We're going to talk about the difference here in just a little bit. You should already know the difference from physical science. But the pure substances, they can only be separated by chemical means. So chemical reactions are what's going to take those elements and turn them into compounds, or the compounds back into their individual elements. So when you think pure substances, I want you to think chemical. Mixtures, you can separate them physically. I can have a mixture of elements, I can have mixtures of compounds, but all mixtures you can separate physically. And the two types, homogeneous meaning same, they're going to be the same throughout, so the sample's all the same. And then heterogeneous, hetero meaning different, so the sample is going to be different throughout the different parts. So pure substances, matter which is uniform and has a definite composition. I can write a formula for it. It can either be an element, which is the simplest form of matter, which retains all the properties of that particular substance. So the simplest form of matter would be the element. That's what we find on the periodic table. We give them 1 or 2 letter symbols. I can take those elements and I can combine them together chemically and form a compound. Here is showing you some pictures of some chemical bonds. When you're working with mixtures, you're just physically putting things together. But if I chemically combine them together, then I have a compound. Follows the law of definite proportions. That's why we can write a formula for it. Water is always H2O. It's never H2O2 or H3O or H4O. Water is always H2O, that definite proportion. And the interesting thing is when I take those elements and I combine them together, I get new physical and chemical properties that can be seen, and the appearance and behavior are different from the original substance. For example, with water, it's made of hydrogen and oxygen, which are both gases at room temperature. When I combine them together, it's now liquid at room temperature when they're chemically combined together. Sodium and chloride. Sodium is a highly explosive metal, and chlorine is actually a poisonous gas. When you take those two and chemically combine them together, you get table salt that might raise your blood pressure a little bit. But otherwise add, the flavorings to most foods that we eat. Mixtures are when you physically blend things together. So when I take those substances, those pure substances, whether it's elements or compounds, and I just physically mix them together, I create what we would call either a heterogeneous or a homogeneous mixture. There's no definite ratio for it. There's no formula for it. You might read a recipe to make a mixture, but you're not going to be keeping track of the exact number of atoms in this and atoms in that. And if I add a little bit more flour to a cookie recipe, I'm still going to get cookies. It's not going to make it something different or something totally new. So a mixture can be heterogeneous or homogeneous. Heterogeneous mixtures are not uniform, so this would be a heterogeneous mixture. This is a heterogeneous mixture. There's 2 different layers in there. That would be like oil and water mixed together. Immiscible is the word that we might use. You might see 2 phases or 2 layers if it's liquids. Examples would be soil, salad, soup. Homogeneous mixtures are going to be uniform throughout. So if I take a sample from the top, the middle, and the bottom, it's going to be the same. Think about like toothpaste. If I use toothpaste at the beginning of the tube, middle of the tube, end of the tube, I want it to be the same. So that's a homogeneous mixture. If there's only one phase visible, like a compound, but it does not follow the law of definite proportions, meaning I can't write a formula for it. It's not going to have just basic elements chemically combined together. That's going to be a homogeneous mixture. We also call these things solutions. You have something dissolved in something else, like a solute dissolved inside of a solvent. Salt water, Kool-Aid, paint, those are all examples of homogeneous mixtures. So we're going to do this activity in class, comparing pure substances or mixtures. So this whole slide we will do in class. Some basic properties of matter. We have physical properties and chemical properties. Physical properties are what you observe. You're not changing anything. You're just going to use your senses. You might boil it to see what its boiling point is, but I still have that substance. If I take water and I boil it, I still have water. I'm not chemically changing anything when I change state, when I go from a solid to a liquid to a gas, or a gas to a liquid to a solid. So these physical properties are just things that you look at and you get the physical characteristics of it. It's how you would describe something to somebody else. So the properties of the ball, you might say it's bouncy, it's solid, smells like rubber, it's round. You might say what color it is. Extensive properties, these are based upon the amount of matter. They're not really useful in the identification. I just have this much. I have this much volume. Many types of matter can have the same properties. They're both the same temperature. They're both the same, like here's the mass and volume and the phase. All of the stuff in here is, going to have the same mass, the same volume. Those are extensive properties. They are just based upon the amount of matter that you have. Intensive properties are not based upon the amount of matter, but they are based upon the individual matters, what makes them unique. Their colors, their odors, their lusters, melting and boiling points, specific heat capacity, density, conductivity, do they conduct electricity or not, their ductility, can I bend them and fold them into different shapes, and then malleability. Again, can I change them and fold them and bend them into different shapes? So these are intensive properties because they all depend upon the type of matter that I'm working with. All right, objective number 5, differentiate between metals, nonmetals, and metalloids. I'm going to show you guys examples of metals, nonmetals, and metalloids just so you can see them. And we are going to label the dividing line on your periodic table. It'll be the first thing we label on your periodic table. But here's some basic characteristics of metals. This should be review for you. There was hidden under the stairs on the periodic table. We're going to draw this staircase right here. This black line is the staircase that we'll draw, and everything underneath the staircase is a metal. So everything that's in red here is a metal. They're highly conductive of both heat and electricity, so we can use them to cook with. We can use them to run electrical wiring with. They're very malleable, meaning we can change their shape. We can heat them up and bend them and fold them and get them to go in all sorts of different shapes for us. Malleable. You can pound them into thin sheets. Gold is the most malleable metal, which is why we use it for jewelry. And then things that are ductile. There's a duck. But things that are ductile just means that I can bend and fold it. Think aluminum. Aluminum is a good example of a metal that's really ductile. They're all solid at room temperature except for mercury. Mercury is a liquid at room temperature, but all the rest of them are going to be solids. And the majority of the elements in Earth's crust are metal oxides, so like iron oxide, calcium oxide, sodium oxide, gold oxide. That's how we find most of the metals in Earth's crust. These metals combined with oxygen in the air. Nonmetals, on the other hand, they are on the top of the staircase. They're mostly gases at room temperature, very poor conductors of heat and electricity. These nonmetals are going to be in the air that you're breathing. Not very malleable or ductile. And the ones that are in solid form, like carbon, it's like a black powder, so you're not going to be able to do a whole lot with it. Same thing with phosphorus. There's white and red phosphorus, and it's just like this powder substance. It's very explosive, but it's a powdery substance. And sulfur as well, a powdery substance that happens to smell like rotten eggs. So you're not going to be able to pound these into thin sheets or use them to make all sorts of different structures like we do with the metals. The metalloids, the semi-metals, they fall along that dividing line. So they actually touch the dividing line. If we go back, you can see they're the ones that are in yellow. So they're the ones that are touching the dividing line. They're the in-betweens. They're the gray area. They're the ones that have properties that fall in between a metal or a non-metal. So depending upon the property or the conditions, they may act like a metal or a non-metal, which is why we call them semi-metals. Most of our electronics, they use semiconductors, so the conductivity depends on the temperature or impurity, so you can have a really good semiconductor like silicone, but it can be, depending upon the temperature, you can make it more conductive or less conductive and how pure it is. So only semiconductors can have one-way electron flow on versus off for like diodes and transistors, which is why we can use them for electronics. You can turn that electron flow off. And that's why they're called semiconductors, because they only have one-way electron flow. So we are going to fill this out together in class, or we'll talk about this in class, but you can go ahead and put this down in your notes. Put this chart in your notes. So if I take a metal and a nonmetal, a metal element and a nonmetal element, and I combine them together chemically, I make what's called an ionic compound. It's an ionic compound because the metal forms an ion and the nonmetal forms an ion, and they bond together. So I'm going to transfer electrons from the metal to the nonmetal. The metal loses the electrons and forms a positive ion called a cation, and the nonmetal gains the electrons. So it's almost like the metal's like, hey, I've got these extra ones, I need to get rid of it, and the nonmetal's desperate to gain them, so they bond together when it takes it. And the nonmetal forms a negative anion. If I have a nonmetal and a nonmetal bond together, I make what's called a molecular compound, or with a covalent bond. You'll sometimes see them called covalent compounds. But I'm going to share electrons here. Sometimes equally and sometimes unequally. I'm going to give you a drawing showing you a polar bond versus a nonpolar bond, and we're going to talk way more about this, both of these ionic and molecular bonds, in a later chapter. I just want you guys to have a little bit of introduction to them. Metal bonding to another metal, you get a metallic compound. And delocalized electrons, you end up with like a sea of electrons surrounding both of the metals. This is pretty rare. It doesn't happen very often. So most of the time we associate the types of compounds as ionic and molecular compounds, and that's, pretty much the only distinction that we make. Ionic is always a metal bonded to a nonmetal. Molecular is a nonmetal bonded to a nonmetal. So here, again, is the dividing chart, or the dividing line. We'll draw this on your periodic table. Everything in green is considered a metal. Everything in yellow is a nonmetal. This one isn't showing the metalloids, but they would be the things that are right along the dividing line. This one does show you the metalloids. Metals, nonmetals, metalloids. So if I have a metal combining with a nonmetal, I make an ionic compound. If I have two nonmetals bonding together, I make a molecular compound. And I also want you to notice that hydrogen, even though it's over here on the metal side because it has one valence electron, that's why it's there, hydrogen behaves like a nonmetal. So that concludes the objectives 4 and 5 for Unit 1.